Imagine you're standing in your room. It's quiet. You say a single word, just one vibration from your throat. Now, what if I told you that this tiny sound wave, this microscopic vibration, didn't just bounce off your walls, but instead instantly disturbed a molecule inside a star, billions of light years away, at the edge of the universe? Sounds like sci-fi, right? But welcome to the bizarre world of quantum physics, where what you do here could theoretically affect what happens over there across galaxies in a split second. This idea, while incredibly strange, isn't just fantasy. It's rooted in a deeply perplexing but real concept in quantum mechanics known as non-locality. At the core of it is a strange dance between particles called quantum entanglement. Let's break this down. Every time you speak, your vocal cords vibrate. These vibrations push air molecules around you, creating sound waves. These waves move out in all directions. On a classical level, they dissipate quickly. Your voice doesn't reach beyond a few meters unless amplified. But at the quantum level, things get spooky. According to quantum field theory, every particle, including the ones involved in your voice, exists not in isolation, but as excitations in a quantum field. These fields are everywhere in the universe. So when you speak, your voice isn't just jiggling air molecules, it's disturbing the quantum field. Now enter quantum entanglement. This is the phenomenon where two particles become mysteriously linked. No matter how far apart they are, across rooms, countries, or even the universe, changing one instantly affects the other. This has been proven repeatedly in labs. When two entangled photons are separated by kilometers and one is observed, the other reacts immediately, faster than light. So how does your voice play into this? When you speak, you're technically altering the field. That alteration, in theory, can have an effect, tiny, almost undetectable, on the entire field across the universe. But if particles are entangled within this field, even across unfathomable distances, your localized action could trigger a reaction on the other side of the cosmos. Einstein hated this idea. He called it spooky action at a distance, but experiment after experiment confirmed it. The famous Bell test experiments in the 1970s and later solidified that the universe doesn't adhere strictly to local realism, the belief that events can only be influenced by their immediate surroundings. So technically speaking, your voice might not travel to the edge of the universe, but its impact on the quantum field could interact with particles already entangled or deeply interconnected across space. And the response? It wouldn't wait for a light signal. It would be instantaneous. But here's the kicker. How is this even possible? In classical physics, information needs time to travel. If you're on Earth and want to send a signal to a star 10 billion light years away, it'll take 10 billion years, even at the speed of light. But quantum entanglement shatters this barrier. It says, I don't care about space or time. We're connected anyway. The implications are massive. Think about this. In the quantum realm, causality, the idea that one event causes another in a predictable, local sequence, breaks down. Events can be linked without any visible or logical connection. It's as if the universe has a hidden, underlying code that binds everything together in ways we can't even see. So yes, when you speak, you're vibrating particles that are part of this all-encompassing field. In theory, the field spans the entire universe, and if particles within that field are entangled, your little vibration, your voice, can cause a ripple that's felt by a molecule inside a star light years away. Not tomorrow, not in a billion years. Now let's get even stranger. Recent theories in quantum information and cosmology suggest that entanglement isn't just a quirky lab trick. It might be the very fabric of spacetime itself. That's right, entanglement may create the geometry of the universe. Space and time, as we know them, may just be emergent properties of deeper entangled connections. So when you speak, you're not just pushing air. You're interacting with a quantum web that stitches the entire cosmos together. Your breath, your sound, your words, they may not seem powerful, But on a quantum level, they're part of this infinite dance of vibration and connection. Let's explore another mind-bending concept, the holographic principle. This idea suggests that everything in our 3D universe is actually encoded on a 2D surface at the edge of the cosmos. So theoretically, every action, even your whisper, gets recorded, reflected, and embedded in the very fabric of space. What you say matters. What you do echoes, not in a metaphorical way, but perhaps literally, etched into the quantum structure of the universe. Now let's ground this in real science. Is there a lab out there where someone's speech triggered a star to explode? Of course not. The effects we're talking about here are so incredibly small that they're undetectable with our current tools. But the point is not whether you can trigger a star, it's that the possibility of non-local influence is real. Quantum physicists continue to explore these ideas, not just to sound profound, but to understand how the universe truly works. Some are working on quantum gravity theories that attempt to unite general relativity and quantum mechanics. Others look at how quantum information might be the foundation of all physical reality. So if you've ever felt insignificant, remember this: you're made of stardust, and your voice, your breath, these are part of a universe-wide symphony of quantum fields, particles, and connections. When you speak, the universe listens, not metaphorically, but fundamentally. And now let's go even deeper. There's another idea in quantum mechanics, the observer effect. Simply observing a particle can influence its behavior. What does that mean for you? It means your awareness, your conscious experience, isn't just a passive experience of the world. It's an active part of it. In fact, some interpretations suggest the universe needs observers to take shape. Without us looking, particles exist in a state of probability, not certainty. This raises profound questions. Are you, by speaking and observing, collapsing wave functions across the cosmos? Is the universe completing itself through your experience? Maybe. Quantum physics constantly pushes us to abandon our common sense intuitions. It tells us that cause and effect aren't always local, that space and time are more flexible than we think, and that everything is deeply, intrinsically connected. You don't need to be a scientist to grasp the poetic beauty of this. Every whisper, every thought, every movement is a quantum event, tied into the greater mystery of existence. We are not isolated beings in a cold, vast universe. We are part of its pulse, its code, its quantum heartbeat. So next time you speak, imagine this. A tiny vibration leaves your throat, somewhere, light years away. A molecule inside a distant star feels it. Not because of magic, but because, fundamentally, there is no there. Everything is here, together, connected, now. This is not just physics. This is the story of being alive in a quantum universe, say where the smallest act might resonate across galaxies. If this blew your mind, imagine what else the quantum world has in store.